Hey guys, welcome back. Okay, so we are on lesson 8. So we skipped over lesson 7, so you do not have to do any part of 8.7. We did skip from 8.6 to 8.8. So we'll go ahead and jump right in on that. So our first section on this is solving a system of equations. Now, this is something we've done before. We did a lot of it once before, back in either chapter 6 or chapter 5. I can't remember which off the top of my head. But we have this system of equations. So 5x minus 3y equals 3 and 2x plus y equals 10. Now, you're going to be asked to solve it all 3 ways. So you'll end up with the same answer in the end, but you are expected to show your work. So make sure you show your work on finding those values, okay, you guys? So for part A, you're graphing it. So you're going to graph out these two equations, and then you'll see where the intersection point is. The next way is by substitution. The third way is by elimination. So with substitution, we need to get one of our equations solved for a variable. So this second equation here is going to be the easier one to do because all we have to do is subtract the 2x. So we end up with y equals negative 2x plus 10. So we have it solved for a variable. Now, we're going to take what y equals, and we're going to plug it into the first equation in place of y. So we're going to have 5x minus 3 times negative 2x plus 10 equals 3. Sorry, I got my equations a little confused there. Okay, so we're going to distribute the 3 to both of these things. So we've got 5x minus, not minus, because we have negative 3 times negative 2, so negative 3 times negative 2 is a positive 6x, and negative 3 times positive 10 gives us a negative 30 equals 3. Combine like terms, so 5x plus 6x gives us 11x minus 30 equals 3. Next, we're going to add the 30 over. So we have 11x equals 33. Divide by 11. I ran out of space, so I'm going to write it up here. So 33 divided by 11, that means x equals 3. Now we're going to take this 3 and plug it in over here. So we're going to have y equals negative 2 times 3 plus 10. Negative 2 times 3 is 6, a negative 6. So y equals negative 6 plus 10. Negative 6 plus 10 gives us 4. And remember, when we do system of equations, it's an ordered pair for our answer. So your ordered pair is going to be 3, 4 on this. So this is by substitution. Most of you preferred elimination when it was possible. Remember, elimination is where you add or subtract the rows, the two equations from each other, and then cancel out a variable. Sometimes you may have to multiply one or both equations by some value to make it so they have the same coefficient. Remember, your variable you're eliminating has to have the same coefficient as the coefficient in the other equation on that variable. So keep that in mind as you're doing these. All right, our next section, we are looking at matrices once again, but I promise this is going to be a little easier than doing the row reduction with the matrices. So, given matrix A, which is the matrix 5, 3, 2, 1, we want to find the additive inverse. So, additive inverse means what can we add to this matrix, or I should say, what matrix can we add to this matrix so we get all zeros in the end? Well, that means we're just writing the opposite signs for all of these. So our additive inverse is negative 5, negative 3, negative 2, and negative 1. If we add negative 5 and 5 together, we're going to get 0. Negative 2 and 2, 0. Negative 3 and 3, 0. Negative 1 and 1, 0. So this is the additive inverse. Your key word for this lesson is inverse, since the next thing we're looking at is the multiplicative inverse. So this means we're multiplying. Now remember, multiplying is a little different when it comes to our matrices. So for this, what we have to do first is find the determinant. So the determinant is taking AD minus BC, where the matrix in a 2 by 2, this only works for 2 by 2s, is in the form A, B, C, D. So this is the form that the matrix is in, and we need to multiply A and D together and then subtract B times C. So A and D would be 5 and 1. So we've got 5 times 1 minus, then we're going to do B and C, which is the 2 and 3. Apparently my cat is going to join us. He's in a mood right now. Go on. Sorry. Okay, so we have 5 minus 6, which is going to give us -1. Excellent. Okay, so that is our determinant. Now we do, for our inverse, we're going to do 1 over the determinant times, now this is the fun part, the rule for doing the inverse of a matrix is 1 over the determinant times D negative B negative C A. So we switch our A and D values. So in this case, A was 5, so now it's going to go down here. D was 1, so it's going to go up here. And then we keep the B and C values in the same place, but we change the sign. So that's going to be a -2 now, and that's going to be a -3. Now, to finish off our multiplicative inverse, we multiply what's on the outside to everything inside. Well, 1 over -1, or 1 divided by -1, is just -1. So that means we're just changing all the signs in this. So our final answer is -1, 2, 3, -5. So this right here is crucial. So this is the determinant. So the A times D minus B times C, that is your determinant. So you're going to take that and put 1 over it and then multiply by rearranging the values in your original matrix to look like this. And this is the form that the original matrix is in. Hopefully that kind of makes sense. We'll go into more depth and more practice with the inverse matrices, multiplicative inverse matrices in the next lesson. This is just sort of a little intro to it, looking at the 2 different kinds of inverses. Obviously, additive inverse is much easier than the multiplicative inverse. And inverse, remember, is your keyword for this lesson, so keep that in mind. All right, our last question, I have it on here, but is ABCD a parallelogram? Provide convincing evidence for your answer. So I'm going to go to the workbook to show you because this is a graphing thing. So I already have it all nice and graphed out for you guys. So given the 4 points, A, which is 2, 1. So right here, 2, 1. B, which is 5, 2. C, which is 4, 5. And D, which is 1, 4. We want to determine whether or not ABCD is a parallelogram. Then you're going to look at, is it a rectangle? Then is it a rhombus? And then last but not least, down there at the very bottom, is it a square? So we've done a few problems like this before. So in terms of a parallelogram, determining whether or not this is a parallelogram, we're going to look at the slopes of these sides. So if we look at the side DC, we're going up 1 and over 1, 2, 3. So we have a 1/3 slope. If we look here at AB, we're going up 1 and over 1, 2, 3. So we also have a 1/3 slope. So these two sides, DC and AB, are parallel since they have a slope of 1/3. we need to look at DA and CB. So DA, from this point, I know my line's a little wonky on here. We're going down 1, 2, 3, and over 1. So it's a 3 over 1, negative 3, because we're going down. And then over here, we're going down 1, 2, 3, and over 1. So another negative 3 over 1. So these two slopes are also the same. If these two slopes are also the same, that means that they are also parallel. So we've got two pairs of parallel sides in this. So does that mean we have a parallelogram? Yes, it does. So I'm just getting this wrote out to make it a little easier on us. So we will say yes, that it is a parallelogram because opposite sides DC and AB have a slope of 1/3 and opposite sides DA and CB have a slope of -3. And since opposite sides are parallel, so since opposite sides are parallel, then ABCD is parallelogram. So remember, we've done these before. So when we're looking, so I'll flip back to this real quick. So when we're looking at this for the rectangle, remember what key things have to be true in order for it to be a rectangle? Well, it has to have right angles. How do we determine that? We look to see if the sides are perpendicular to each other. So you're going to look and see if we have perpendicular sides. So is DA perpendicular to DC and AB? Check that out. With a rhombus, what key feature do we know about a rhombus? Well, we know that DA, AB, BC, and CD all have to be the same length. Remember, a rhombus, all the sides have to be the same length. So use the distance formula to help you determine if those sides are all the same length. And then if it's a square, well, if it's a rectangle and a rhombus, then it will be a square. If it's not a rectangle or it's not a rhombus, then it can't be a square. So keep that in mind as you're going through on these. Now, remember, your keyword for this lesson is inverse. If you have any questions, feel free to shoot me an email, and I'm happy to help you out. Have a great day, and happy mathing.